In this next section, we're going to look at algebraic expressions or polynomials. And we're going to be looking at the different properties associated with polynomial expressions. Things like combining them using our multiplication or addition and subtraction properties, or factoring them, meaning taking them apart and making them smaller factorable pieces. Okay. So to start, I want to talk about our definition for a polynomial. There are many types of polynomials. We are going to look at what we're called univariate polynomials. That just means I'm looking at a single variable. There are multivariate polynomials as well, but for this course we're mostly going to be looking at univariate ones. Okay, so a univariate polynomial is any polynomial of the form a n x to the n plus a n minus 1 x to the n minus 1 all the way down to some constant a0. All of the a's, the subscripts there, are real numbers, so it's a real number times an x to a power, where all of the powers are natural numbers bigger than 0. So notice if there was a 0, it would be on that last one, so x to the 0, but we're going to exclude that. It's just a constant, so it's just a number. Okay. So some of the properties that we're going to see with our polynomials, obviously the addition and subtraction we'll be doing, and again multiplication. Division of polynomials we'll talk about a little later. There are some what we'd consider basic division of polynomials, but most of them are going to be a little bit more involved, and we're going to use them for specific things. So we'll talk about those in a later chapter. But our basic properties here for addition and subtraction, this just means I have two polynomials with the same variable that I'm trying to combine. And the main thing to do here is exactly what I just said, which is to combine terms. And in particular, we're going to look at what we call like terms. Okay? So an example here would be something like 3x squared plus 5x minus 7. Let's say I wanted to add that to 2x to the fourth plus 3x cubed plus x squared minus 5x plus, let's change some signs in there, minus 4. So let's say those are the two polynomials that we want to add. And again, subtraction is very similar. The only difference would be I need to distribute. Okay, so by like terms, it means I'm going to find the ones that have the same power. I don't care about that number out front or the coefficient. I only care about the exponent. Okay, so in this case, when I go to simplify, I can see there's only one x to the fourth term, only one x cubed term, and then the x squared, I'm just going to use those operations. So 3 of those plus a negative 1 of those, looks like 2 of them. 5x plus a 5x looks like a 10x. And then negative 7 plus negative 4 looks like negative 11. So there's how I would go about adding or subtracting two polynomial expressions. I'm just going to find the common terms and group them together and perform the operation. Okay. For multiplication, to solve a multiplication of two or more polynomials, I'm basically going to use distributive properties. And if you listen to how I said that, I do actually mean plural there. So it may not just be one distributive property, it depends on what I'm multiplying by. Okay. So for example, I could have just a single term being multiplied through. Okay. And then here it's just a single distributive property. I'm going to take and apply that distributive property to each term. Okay, so I would get a 12x to the third plus 15x squared minus 3x. And notice here, again, when I'm multiplying, remember I'm multiplying like bases, so I have to add those exponents on those x terms. That doesn't happen here because I'm not multiplying. Okay. If I have more than one term that I'm multiplying by, so for example, let's say I have a 2x plus 3, and an x minus 7. Okay? Then here, it's more than one distributive property. So I have to think I'm going to take that 2x and distribute it to each term, but I'm also going to take that 3 and distribute it to each term. So here I would get a 2x squared minus a 14x. So that's taking my 2x through, plus my 3x minus 21. Okay, so there's taking my 3 all the way through. And then I'm back to addition of polynomials, so I'm going to combine like terms. So in here I can see this is going to simplify to 2x squared minus 11x minus 21. Okay. And it doesn't matter how many terms are within each polynomial. That's why this is pluralized. I can distribute each term to each term in the next set of parentheses. If I had 3 sets of parentheses, I'd work with the first 2, get that answer, and then distribute to the next set of parentheses. Okay, so use your distributive properties. Another set of properties that we have are what we call our special products. So we have kind of this notion that we can do all the time, but some of our polynomials are of a particular form, and so instead of doing this distributive property, we have a special formula that you can remember to actually get your solution for them. Okay, I'm going to use 2 different colors here because for our distributive properties, they also lead into what we're going to do next, which is factoring. Okay, so these special products I'm talking about can go either way, and I'm going to talk about that a little bit more in just a second. Let's look at our first property. So our first one says that if I have A and B, which are some expressions, I'm just going to use A and B now, but A could be something like 2x and B could be 3. Or A could be 4x squared and B could be 5x. Okay, so if I have 2 terms in my polynomial, whatever they are, and I'm multiplying by a polynomial that has those same terms but a different sign, then this is going to equal A squared minus B squared. Meaning when I multiply out and combine my like terms, those middle terms will cancel out and I'm just left with A squared and B squared. Okay. My second property says that if I have the same term with the same sign being multiplied by itself, this is going to equal A squared plus 2AB plus B squared. Okay, so when I multiply out those middle terms, it's just going to be twice the product of the first and the last term. Okay. Similarly, if my terms are the same and I have a minus sign between them, then this looks very similar. The only difference to notice is that instead of a plus sign, I'm going to get a minus sign. Okay. And another set of products that you're going to want to know, and I'm going to kind of write these together because, again, they work similarly to the A plus B squared and A minus B squared, except now I've got cubes on them. When I go and multiply out, with the positive, things kind of accumulate, but they accumulate in a nice pattern. So this pattern that we got here, 1, 2, 1, for these, there's a similar pattern for the cubes. I'm going to get an A cubed plus 3A squared B plus 3AB squared plus B cubed. So 1, 3, 3, 1. If I look at those coefficients. And nicely, if I'm doing the subtraction, I'm going to get the same terms. The only difference is the signs on them. So the signs are going to alternate. Okay. So those are 4 of our special products. And like I said, there's some nice things about these special products. If I look at them in terms of whether I'm trying to expand an expression, meaning multiply it or add it out, or whether I'm trying to factor, meaning get the smaller factors of it. So if I look at going from the blue to the purple or red, however this shows up, so if I'm going in this direction, this is what we call expanding polynomials. Okay, so moving from the left to the right is my multiplication or expanding these. I'm going to FOIL them or distribute them or multiply them out, however you want to say it. They're expanding to bigger polynomials and putting them back in polynomial form. If I go in the other direction, so towards the blue, this is what we call factoring polynomials. And so in this case, I'm taking my polynomial expression and putting it in a factored form, something that's easy to work with that I can use for simplification or solving or things like that. Okay? And so these special products, you want to know them both ways. I would say these first three are the most important in terms of the factoring, and there are a couple others we'll put on there. But for the expanding, the last four are the ones that you're going to want to know more often. Or even I would say the last two or three, because those are the ones where multiplying it out gets a little tedious because I have higher powers here. So other factoring techniques that you're going to see, again, just like those ones we talked about with the special products, you've got to be a little careful in how you're looking at things. So to continue with the special products and factoring, there's a couple more that we want to look at when we go to factor polynomials. Now, these first two that we're going to talk about, you want to be careful not to confuse them with the last two special products we talked about. So the last two special products, we looked at a plus b cubed and a minus b cubed. Here, we're actually looking at the cubes on the actual terms or expressions. And so if I'm looking at an a cubed plus a b cubed, I can use my factoring properties. And again, these are formulas that you're going to want to know. It says it's going to start similar to what we had before, which was a plus b, but then cubed. The difference is I don't have any middle terms here. And if you remember in the special products case, we had 4 terms for that cubed. So to get rid of those other middle terms, I'm going to multiply this by a squared minus an ab plus b squared. Okay, so I'll take my first term and the last term, square that first term, square the last term, minus the product of the middle two. Notice here that the sign is the same as what's inside between my terms here, but it's different for that first term in the trinomial. Okay, so the same thing here, except now my signs are going to change. So this will be an a minus b, a squared plus ab plus b squared. And notice in both cases that b squared is positive. And again, that's because when I multiply those last terms, I need the sign to match up there. So that's what's going to give me the negative b cubed. Okay. The other technique that we're going to look at is what we call factor by grouping. And that's when I have more than 3 terms or 2 terms, and I can't see something that's common in all 4 of them, so I'm going to pull out groups and factor those down to see if I can continue factoring. Okay? So in this case, if I've got an expression that looks like this, okay, I can notice here that in these terms, I have both my a's and my x's, and here I have both b. So if I kind of rewrite this, I can group things together and then factor out within those groups. So here if I look at ax to the n plus cax to the n plus b plus cb, then I can group here, I can pull out ax to the n, and I'll see I'll get a 1 plus c And here I can pull b out, and I get a 1 plus c. And so I factored the groups, but I'm not done because this is still two separate terms, and I want to get it down to one term, meaning no addition or subtraction signs separating things. And so here I'm going to pull out what's common in both of them, which is the 1 plus c and the axn plus b. So from there and there. Okay, so now I've got it down to one term. Okay, now this may not have made much sense in terms of how I go about factoring that down, but I want to show you where this is useful. And this is useful in what we call our master product method. If I give you a polynomial and I ask you to factor this polynomial, then what I want to do is I want to get it to be 4 terms so that I can factor them down and group them together and figure out what the terms are. Now some of these polynomials you're going to be able to look at and factor, and that's fine. But there are going to be some polynomials that you just can't try all of the terms, or you can't just look at it and figure it out. And so that's where this comes in. Okay? So this method says first thing I'm going to do is I'm going to multiply my coefficients and my constant term. And from there, I want to find 2 factors of that are going to equal that middle term. That middle term, I care about the signs on all of these. So if I have negatives in there, I want to make sure I include the negatives in these calculations that I'm doing. Okay? So here I can see 24, I can think 6 plus 4 is going to equal 10. So there's the terms I want. Now, this may not seem so useful, but again, the idea is I want to rewrite this polynomial into something I can factor and group. Okay? And so if I think of 6 and 4 as replacing this 10, I can think of my polynomial as 8x squared plus 4x plus 6x plus 3. Okay, so I've replaced my 10x with 4x and 6x, and now I'm going to group these. So I'm going to look at these first 2 terms and factor them. So we can see I can pull out a 4x. I'm left with 2x plus 1. Don't drop those 1s. Remember, you're multiplying by something to get that term. And then same thing over here. I can see there's a 3 in common in both of these. So I can pull a 2x plus 1 out. Okay. And now that I've grouped and factored, I'm going to factor one more time, pull out what these 2 things have in common, which is 2x plus 1. And then what's left over is just a 4x plus 3. And you can check that. You can see if I go ahead and multiply these 2 things together, I'm going to get an 8x squared plus a 4x plus 6x, which is 10x plus 3. Okay. Now all of this factoring is going to come back into things like this. And so you got to remember, most of the stuff what we're doing in this pre-calc class is for your later classes. So for those of you going on to take calculus or Calc 2, Calc 3, differential equations, linear algebra, you're going to be using all of this mathematics there. So here we're showing you kind of all the steps, and this is what it's going to look like later. I'm going to have polynomials like this that I need to be able to simplify. And so now if I put all of this stuff together, I can simplify this polynomial. Okay? So here I can see I have 2 terms, and I want to factor things out to simplify it down. Now remember, there's a difference between reducing something and expanding it. And when we say reduce or simplify, we want to make the number of terms less. So I want less than 1 plus or minus sign here to separate my terms. Okay? And so here, I'm going to start by, just like what I did here, I'm going to pull out what they have in common. So if I look at these terms, I can see there's an x squared minus 4, that's common in both of them. And there's 4 of those. There's a 2 in common, I'm going to pull that 2 out front. And then there's an x plus 2 cubed, that's common. Okay? And then if I look at what's left over, well, from this term, we have 5. We pulled out all 4 of those. We got the 2. We still need an x. And we have 3 of these. so I need one more. Okay. And then same thing here. If I look at this second term, I have 4 of the x squared minus 4, so I'm going to need one more of those. From the 4, I pulled out 2, so I'm going to need 2 more, and I have all 3 of the x plus 2's. Okay. So I factored this down, and if we look, this is all one term. That term's not very pretty. It's not simplified, so we're going to clean that up a little bit. And some of our factors aren't very pretty. If you notice, those are some of our special products or special factorings. So I can simplify. X squared minus 4 is a difference of squares, so that's going to be an x minus 2, x plus 2. But I had 4 of those, so when I factor it, I'm going to still have 4 of each. Then I have an x plus 2 cubed. Okay. And then inside my grouping symbol here, well, these are distributive properties. So 5x squared plus 10x minus 2x squared minus 8 plus 2x squared minus 8. Okay. And I'm not quite done. I can clean up a little more in that bracket. But also, I have like bases, different exponents. I'm multiplying those together so I can add those exponents. So we'll have an x minus 2 to the 4th, and x plus 2 to the 7th, and inside that grouping symbol there, I'll have 7x squared plus 10x minus 8. And I can actually take that one step further because that last polynomial can factor a little bit more. So this is going to be 2x minus 2 to the 4th, x plus 2 to the 7th. I can take that down to 7x and x, 14 and 4, so minus 14 plus 4 to give it. Okay, and you'll notice there's a common base there. Instead of rewriting one more time, we're going to combine those x minus 2's to make that a 5th power there, and then 7x plus 4. And so this would be what we'd consider our simplified expression. Why is this simplified compared to that? 2 reasons. One, because there's less terms here. Remember, terms are separated by sums and differences, or pluses and minus signs. Here there's 1 term, here there's 2. And second, this is simplified because now if I'm trying to solve an equation where this is equal to, say, 0, I can solve it directly. If this is an expression that's being divided by some other expression, I can now cancel like factors, so I can simplify things down. So this is why our simplifying and our factoring are important. And that's one thing that a lot of students don't understand. So when you see something like this and it says simplify, you don't want to expand it and multiply it out. You want to take it down so there's less terms and it's clean and concise, so that if I had to solve or simplify further, I could do it from the expression. Okay, so that's it for the polynomials. Like I said, you'll see some of these things in later sections because we're going to be using all of this again. And for this section, when you go to your textbook or when you go to the homework problems, you will see a couple of problems like this that put all of these properties together. And again, you just want to take them one step at a time. But these are things you're going to later see in your calc classes.